All right, good afternoon, everyone. My name is Greg Truty. I'm Chief Architect of our IBM MobileFirst portfolio. It's basically our MobileFirst brand of which we're aggregating all of our mobile capabilities for within IBM itself. Today I'm going to talk a little bit about the IBM partnership with IBM Worklight, a little bit more in detail. Since this is a developer conference, I'm going to walk through a little bit of the high-level value proposition of Worklight itself. I'm going to talk a little bit about how we're integrated into Worklight, and then we'll walk through kind of an example, a development example, and if there's time at the end, I hope to basically kind of re-emphasize some of it, showing you a live demo for some of the work. From a Worklight perspective, from a value proposition perspective, Xamarin really helps take care of a lot of the front-end coding, the front-end development across the multiple platforms. That's what it does well. What Worklight does well is it's really a platform that runs on the server that helps with three fundamental areas. Area number one is with enterprise integration, making it easy to connect up to systems within the backend itself, being able to leverage existing services, stream them down, transform the data itself as part of that. Value proposition number two is dealing with mobile security, security and trust, single sign-on, device provisioning, multi-factor authentication. A lot of that we've built into the platform to alleviate the need for developers to actually have to get involved too deeply as part of that. The third value proposition is with application management. Managing the application itself, managing versions of the application, getting analytics and information about what's happening on the application, what's happening on the backend system, and providing a nice simplified set of metadata, set of analytic data back to users and developers for them to figure out what's actually happening within their application, not just the front end side of the application, but all the way back within the enterprise itself. From a Worklight perspective, Worklight consists of a number of different things if you were to purchase Worklight. It consists of a runtime server. The runtime server is what actually runs within the enterprise itself. There's a set of application runtime components, client APIs. In the Xamarin case, these client APIs are actually part of the Xamarin components, and we'll get into that in a little bit. There's an operational console to manage the Worklight server and the applications themselves. And then there's a development studio, but there's also a command line interface, and again, that command line interface is the primary interface in interacting from a development perspective with the Worklight server. And again, I'll get into some more pieces. There's another piece of Worklight that comes with respect to being able to actually have kind of a developer app store, to be able to simplify the delivery of apps to your developers to make it easy to use. As we were developing apps and working with customers, developers wanted a simple way to actually distribute these apps. So that's part of the Worklight component. The integration specifically focuses on leveraging Xamarin on the client side, picks up and uses and leverages a Worklight component on the client side, and then it integrates into Worklight for it to provide all of its sort of value proposition. So it's kind of a marriage made in heaven. So what's this do for developers? Well, it allows, leveraging Xamarin allows you to speed development from that perspective. Leveraging Worklight allows you to leverage some of the base security features, some of the base integration features out of the box, giving the developer a nice set of tools to be able to customize the data specific for their mobile application. The speed of the integration, again, that's part of the value proposition of what Worklight offers. Leverages robust security. So from a security perspective, we've done integration with a number of different security proxies, a number of different security systems. In many cases, we leverage whatever the security model that the enterprise is already running within the enterprise itself. You can wire in rich app services, whether those services are on the client side with the Xamarin toolkit, or services are on the server side, calling out to other server-side services, other cloud services, and being able to compose these things. That's part of the value proposition of what we're trying to do in Worklight. Ease troubleshooting, part of the APIs, the capabilities are going to actually start collecting some data about the application. There's logging APIs as part of the application that you can actually view on the server side to see information of what's actually happening on the client side itself. And then tie that into logging APIs on the server side to actually get a mixed message so you fully understand what's happening with your application. And then getting control of your applications, being able to actually, again, understand what users are doing and being able to actually help govern the lifecycle and the rollout of this. There's a term called Bluemix that actually IBM has. It's really our cloud-based infrastructure that we actually have that we're developing as our premier platform. You're going to hear more about it in the coming days, but the idea here is we're actually adding cloud-based capabilities that we're going to start delivering, that we are delivering a number of server-side capabilities API-wise. And a lot of these APIs are things that you can actually leverage within your application, either directly from the client or through the Worklight server. Things like Watson Analytics, CloudInt, our NoSQL backing store based on CouchDB. Other third-party APIs like Twilio to actually send messages are all being integrated into our IBM Bluemix cloud-based runtime, so something to be aware of. From an enterprise integration perspective, the typical model is developers are going to build the app with Xamarin on the client side. They're going to stub out the application itself, understand what are the APIs, what are the interfaces that they're going to actually have to surface up that data to the enterprise itself. And then the next part is to augment the app with filling in the controller underneath to actually get the data to populate the model such that it can actually be viewed. And those requests are going to be going across HTTP or HTTPS, pulling back JSON data, specifically tied to the application, and then again, fetching the application from the backend systems itself from a data perspective. So Worklight provides that single point of capability. And the patterns that we found, the reason why you would want to leverage kind of a special mobility server as part of doing that is in many cases within enterprises expose APIs that are actually fairly heavy. They pass back tons of data. The tons of data are typically going to web applications. Trying to strip that down, narrow it down, transform it to be just right for the application developer, we found that application developers wanted the flexibility themselves to tweak the APIs such that they can actually get a set of APIs that allow them to change or change the API as they're changing the application to give them ultimate flexibility and power to be able to actually get that application right from a user experience perspective. A lot of the integration from a Xamarin perspective is going to be through the command line interface. Now, the command line interface of Worklight really actually has a full-blown application server sitting underneath it. That's what the Worklight system is actually running on. With this command line interface, you can actually create artifacts that represent the application. You can create a concept called adapters, and we're going to talk a little bit about that in the coming slide. Adapters are effectively how you fetch data, get data, integrate in with the backend system itself. You could deploy the adapters. You could start and stop the Worklight server, et cetera, all as part of that. The life cycle for what this means to a Xamarin developer is going to follow a little bit like this. First time, they're going to download the IBM Worklight command line interface. And they're also going to install the IBM Worklight component within the Xamarin Studio. If they're going to create backend artifacts representing API calls to be done, they're going to effectively, leveraging the command line interface, develop these adapters, these procedures to be able to actually return data back to the client. They're going to then leverage them from the client side itself, build, deploy the application. And then they could effectively leverage the Worklight console, the Worklight Analytics console to be able to actually understand what's happening with the data themselves. Because I want you guys to be able to understand and be able to do this yourself. I'm actually going to walk through the steps a little bit to get you a feel for kind of the process that you would actually go through. And you could actually refer to this back a little bit later on. But today, as part of the integration, what went live is effectively our IBM MobileFirst SDK. This is the Worklight SDK. These are the .NET assemblies that are actually going to go within the Worklight application itself. I'm sorry, in the Xamarin client application itself. And you fetch it like you would any other sort of third-party component from the Xamarin IDE. A couple key points here is we are initially starting support for Android and iOS client-side applications as part of that. So the component will allow you to, again, leverage the Xamarin capabilities for building native applications for those two platforms themselves. All of the documentation is there as embedded in the component itself. So if you want to get more information than what's available in the component, you can actually open up the component itself. You'll see a full set of docs, a full set of command line APIs in order to call. The samples are under there. Information about how to use it is all under that component. Part of that component actually has an add-on. The add-on actually adds a set of additional APIs under the tools component representing IBM Worklight. You can start and stop the server. You can open up the Worklight console directly from the Xamarin IDE, as well as see what version that you're actually running under. Whether you use those interfaces or leverage the command line. It's totally up to you from a user preference perspective. Part of the configuration into Xamarin is basically to point to where is the command line interface, where did you download it, where did you install it. There's a default location for that typically gets installed that we prime with the application itself. There's also a location to a JDK in order to actually run that actually gets configured. Again, we're defaulting to use the one that's installed within Mac. The process to create a Worklight application, again, we want to be able to manage this application artifact from the client side. By managing the application, what we really mean by that is being able to actually issue messages, disable the application, provide maybe multiple versions of the application management if you have different versions of the client-side app that you effectively wanted to control independently. So you may release a new version of the app. A lot of your other clients may not necessarily migrate off the old version. This gives you the ability to eventually shut off that old version or force them to upgrade it. And again, we'll get into a little bit of how that's going to work in the coming slides. The model to create a Worklight application, or at least the artifacts that are going to represent this manageable component, is you're going to create an API, a project. In this case, I called it xtest. You're going to add an API. You're going to define it an environment. So in this case, if I want to create two different environments, one for iOS, one for Android, you would effectively add an API for xtest Android and xtest iOS, specifying the appropriate environment. The key part about this is what you're going to see is a project structure which contains metadata under that Android project or metadata under that iOS project. And there's going to be a set of property files in there. A WL client properties for Android, a plist for iOS. These are key. This is what you embed, what you will embed in your client-side application, and it contains the metadata to say, where's my server located? So that's where you're going to specify your server information to let the client know exactly where the server is. There's a command line interface in order to actually build those artifacts. So it builds a bundle containing the metadata. If you have to start the Worklight server, you could start or stop the server from the command line. And then you deploy the bundle. You deploy the artifact to the Worklight server. So at this point in time, you now actually have an application defined on the server side, which is going to be available in order to actually take APIs and to be able to manage and govern that application. On the client side, remember I said that there were those two key properties. There's a WL client properties file. In Android, you're going to want to add that as an asset because this is one of the things that as we initialize Worklight, we're going to have to find out where's all of that server configuration, where do I want to find that? And we load it a standard way of just loading any sort of asset bundle from an Android perspective. From an iOS perspective, a similar sort of thing. You effectively add the plist as part of that structure itself, and then you add it as a bundled resource. Now, from a best practices perspective, the way we certainly structured our sample applications, the way I structured the demo application that I'm going to showcase a little bit later that I actually did with the Xamarin team, is there's a common component in where all of our logic is actually going to be. There's an iOS and an Android component. In this particular case, you see the iOS package of the project itself, and then we actually have a generic component called where we're putting all the Worklight code. So the interesting thing about this is what you're going to see is there's effectively one file, one little API call that's going to get done each in the iOS and the Android bundles. All of the Worklight specific code following this pattern is going to go into the Worklight project structure itself, and then everything else is common code. So again, facilitating on the client side a bunch of reuse from a project structure without permeating a lot of the Worklight logic throughout the infrastructure items themselves. This is effectively what the project structure would be. Again, following this best practice, you would define referencing your mobile banking Worklight project. This is what's going to pull in all of the code containing the Worklight infrastructure in. And then you're going to define a header pulling in the Android code specific to Xamarin and effectively initialize it. So the only line that's actually unique here is the fact that you've specified that you need the Android client initializer, and you're effectively going to initialize that Worklight banking client interface with a create instance of that Worklight client. So that's enough on the Android side to initialize Worklight. It'll read the Worklight WL client properties file from an Android perspective and issue the request. Again, very similar in iOS, except in this particular case, you're leveraging and pointing to the iOS specific version of the code. And again, during the finished loading section of the iOS app project itself, you would then initialize the Worklight client with it. Now, in order to facilitate this enterprise integration aspect of it, Worklight actually has a concept of adapters. And adapters really actually have a runtime component. And the purpose that we did adapters within Worklight itself is to make it trivial in a mobile-friendly way, right, dealing with JSON structure and JavaScript APIs, to allow developers, independent of a enterprise service API requirement, well, I should say set of changes by a different group owning the services and APIs, which is typical in most enterprises. We wanted to empower the developer. So we've created a concept called an adapter. The adapter is basically where developers would actually take code, modify code, strip down the code to get it to fit what is just necessary in order to improve and limit the data that's actually going to the mobile client itself. It also represents a place where they can actually do service composition, and they can actually add in other JavaScript codes, do transformations, do XSLT transforms of XML to strip down the XML, and then Worklight will automatically convert that to JSON in order to send it to the client itself. Adapters is also where we do all of our security integration. So if you want to customize the security model, you could certainly use adapters as a way to do that. An example of this is I know customers today, a financial institution, a bank, that actually have 3 different security models that they actually log in, depending on what you're doing, whether you're actually using a credit card, whether you're using a debit card, or whether you're doing wealth management, because they were 3 independent systems that they bought them out. Adapters is one of the way that they effectively allow developers to log on to the appropriate service through that common adapter model from that perspective. Part of when you go through adapters, we also start auto-collecting analytic information about the client request, information of it coming into the server, such that we can actually give round-trip information back to the developer, not just of what's happening on the client side of log information, but what's happening on the server side and how long things have taken to effect, such that you can actually get some insight as part of what's taking so long on the server side, such that you can actually help debug and diagnose and point fingers, so to speak. It's also where mobile user engagement for push notifications back to the client could also be done. The development environment for these adapters are JavaScript. We did JavaScript because we wanted a simple model that would make it trivial for developers to actually code to. And then for the client-side developer, that procedural invocation model provides a nice, consistent interface that they actually use to invoke. Let me make a couple of other comments. From an adapter perspective, we support adapters to JDBC, adapters to other HTTP requests, JMS requests, pure REST APIs. We've done integration in with our cast iron product. We've done integration in with our message broker product. Our message broker product actually auto-gens adapters if you're starting from the server-side data that you actually want to configure back in itself. Our ESB portfolios, you can extend it with Java. Lots of things that you can actually do with adapters, so very flexible. From the client side, what's an adapter invocation look like? An adapter invocation pretty much is fairly standard. The adapter invocation basically specifies the name of the adapter that you actually want to deploy. The adapter will have a name, a procedure name of what you want it to do. So in this particular case, I'm going to show a banking example. The banking example is going to transfer some funds. And then I'm going to pass it some information about the transfer. What account is it transferring from? What account is it transferring to? And what's the amount of the transfer? And then I'll invoke the procedure and wait for my results. Again, this should look very familiar from a Xamarin perspective. On the server side, this is a little bit of what a procedure method looks like within an adapter. There's a function call with the name get transfer funds. I wrote a simple little adapter here to basically keep track of a little JavaScript global process in order to actually keep track of the funds themselves. But this JavaScript can do anything you want. You could actually have it call out to other requests. In this particular case, here's an example where if I wanted from this adapter to make an HTTP request, I can actually invoke a server-side method called invoke HTTP. I could actually tell it what parameter, a GET or a POST request to actually issue as part of that. I can say whether the content is XML. I can specify, is there an XSLT that I want to run against some enterprise XML that's actually coming back in order to strip that data down. I can invoke other procedures, so I can actually start aggregating and composing systems itself. There would be a invoke method for SQL in order to actually invoke JDBC as part of that same sort of model. So again, a very flexible mechanism, a very simple mechanism for developers to actually code these things up. Part of an adapter configuration will actually have, for those invoke methods, a policy in order to define what connections that you actually want to go out to. Here's a case where that invoke HTTP method will go out to rss.cnn.com. It'll talk HTTP. It'll talk to a specific port. This is how we specify the metadata that the adapter is going to use in order to actually make outbound calls as part of that. Every method that you actually want to introduce on the client side will have a corresponding method within the adapter on the server side. In this particular case, for the banking example that I'm going to show, it's going to drive a login. It's going to drive getting a list of accounts for a given user. It's going to define getting a set of transactions for a given user itself. And then it's going to drive a getting transfer of funds from that perspective. The process of creating an adapter, very similar model to creating an application. Leverage that Worklight command line interface. You're going to add an adapter. You're going to give it a name and give it a type. Again, from a type perspective of whether it's JMS, whether it's SQL, whether it's HTTP, we're going to gen out the right defaults to give you basically a starter template to allow you to very simply get started from that perspective. When you do that, it's going to create a project structure that looks like the following. It's going to have an adapters folder. Under the adapters folder is going to be the name of the adapter itself, and it's going to have 3 files. There's going to be an empty JavaScript file with a couple of default procedures, so you can actually go in, duplicate exactly what those procedures are. It's going to have an XML file. Again, that's that configuration we saw a little bit earlier. It's going to have an XSL, which is going to be a sample XSL script to show you a little bit of how to actually strip down it if your data is XML as part of that. You're going to edit the adapter. So you're going to basically use your editor of choice, modify the JavaScript, add the JavaScript code at that point in time. And again, similar to what we did with the adapter, do a build, do a deploy of that information itself. Now, once the adapter is deployed, we actually have mechanisms for you to easily test the adapter. So in this particular case, and there's 2 ways to test it. You can actually test it interactively, or you can test it directly. In the interactive case, you'd issue a WL invoke. It's going to take a look at the adapters that are actually deployed within your project, and you're going to select the one that you want to do by using the arrow keys. It's going to then return some metadata to say, OK, now there's a set of procedures. Which procedure do you want to call? And then you'll enter whatever parameters that you actually want to pass into the adapter as common separated artifacts, and it'll invoke the adapter and return your little JSON snippet back and forth. So again, this gives a nice, simple, lightweight mechanism to test the server side sets of capabilities that you're actually going to call before you actually go on the client side itself. From a direct invocation perspective, you could certainly specify all that metadata up front, and again, get that same sort of result back. So this is how you can actually test your adapters prior to actually then leveraging them within your Xamarin project. We actually have capabilities to do adapter generation for SOAP and SAP requests. A lot of this is actually driving, trying to integrate into a set of existing enterprise services that exist today within the enterprise, and these are the 2 most specific types of enterprise integrations that we allow you to do within Worklight today. But the whole purpose of the wizards, and these wizards are part of our Worklight Studio part of the side. The whole purpose of these wizards is to actually walk you through a wizard to make it as easy as possible for a developer to actually get the metadata set up in order to actually invoke it on the server side. I know that Xamarin actually has some SAP components, right, for doing integration from the Xamarin side. But Part of the interesting thing here is this allows you to strip down the code that's necessary for that last mile going between the server mid-tier all the way back to the mobile client itself. You're going to find that you're probably going to want to augment the data, modify the data, strip it down, right? Get it just to be right such that you minimize the amount of data that's returned in order to actually try to improve that user experience back to the client side itself. From a push notification perspective, because we are supporting Android and iOS in the first release of what we actually have as part of the Xamarin Worklight integration, you could certainly leverage, or we certainly integrate in with Google Cloud Messaging and APNS in order to actually manage the push subscriptions, and Worklight provides that push broker itself. So if the Xamarin application that's being written is an iOS application or an Android application, what we've done in Worklight is to abstract out those APIs such that the developer doesn't actually have to care which device is actually getting registered. All of the push registration, the push tokens are automatically going to be handled by Worklight itself, and it's going to expose a unified API such that you can then notify customers on a number of different things. You can notify specific devices. You can notify the customers once they've actually logged onto the system itself. So we're keeping track of what user IDs are associated with what devices. That suddenly becomes now a mechanism to do notifications for. You can register subscriptions, or I should say you could subscribe to different events on the server side. You could register a set of tags that a given client is actually interested in. So for example, let's say you're building a Xamarin app that's going to effectively allow preferences and subscriptions to a number of different things. You could define tags for each one of those things and let the user select what tags of the things that they're actually interested, and then do group broadcasts back to just the parties that are interested in just that notification itself. And Worklight effectively manages that infrastructure, that mapping of the device tokens and the informing of APNS and Google Cloud Messaging all in a simple, easy fashion. From a security perspective, that's that second value proposition. Security-wise, that's really the biggest concern from an enterprise perspective from CTOs. There was just the best practices session that took place today for security that we've heard from a number of different users. There's a number of key features that we actually built into Worklight as part of this. Some of these features are capabilities that exist today in our Worklight portfolio that we're actually adding into the Xamarin portfolio, so we've graded some of them out for right now. But the ones that are important from a Xamarin perspective are the ones that are there in black. We have a mechanism to have different types of challenge response handlers. So you can actually configure the type of security that you actually want on the device. We actually have authenticity checking. We have, and we've tested that we're compatible with jailbreak and malware detection. ArcScan itself, we're compatible with. Some of the Trusteer work that we actually have we're compatible with. The ability to remotely disable the application, again, that's part of our application management feature. We actually have a set of application security features to actually be able to tie into different security realms on the server side, depending if you have to log into multiple places, depending on who you are. There's a whole custom integration framework as part of that, and I'm going to walk through a little bit about some of this stuff. But we've pre-established a set of patterns that we're already working with a number of enterprises that are now available as kind of templatized cookie cutters in order to actually help integrate with customers themselves. From a Worklight perspective, there's three fundamental concepts in security. The first is a definition of security tests. A security test defines a configuration for a protected resource. So as an example, you may want to protect an adapter. It's going to have a set of security tests. The default mobile security test that's relevant from a Xamarin perspective is we actually fingerprint the device. We create a device ID which represents each device uniquely, and we want to make sure that before any request comes into the system that we've already provisioned a unique device ID such that we can then understand who's actually calling us. This is important. If we find that one device is abusing the system, we can actually shut off that device. The second is a notion of realms. Realms are resources protected, realms are protected by authentication realms. These realms can be interactive or non-interactive. So as an example, an authentication realm could be a forms-based login. That's something that's an interactive login. Another realm could effectively be an adapter-based login, right? That I actually want to drive my security model slightly differently. I want it to be configurable. I want it to be customized. And then as part of that, there's authenticators and login modules where that login form actually collects the credentials. And then the login module actually is the one that actually validates the credentials. We've tried to strip it down and make it as simple as possible. But the key here is that once you've done the integration for security once, you can leverage all of the configuration that you've done in a declarative fashion, and it alleviates and removes that burden from the application developer. They can just specify the configuration in a declarative fashion, and security is handled for them under the covers. What's this mean for an application developer? Well, from a security test perspective, they would actually drive and add a security test to the procedure itself. That's what they would define to the procedure. From the specifying of all of the security config, and again, this typically gets done once within the enterprise, once you've actually set up and actually configured this. There's a file under the server configuration which represents everything about your authentication configuration. In this file defines a set of security tests, and again, here's the sample security test that's actually in there. It's the one that by default checks for a device provision, but this is a customizable sort of thing that you can actually have multiple different tests for multiple different realms if you actually wanted to. For each realm, you can specify a login module as well as a class name to actually handle this. So remember I talked a little bit about forms-based login, so this is effectively what tells the runtime that it wants to use the forms-based login. And then lastly, from a login module perspective, in this particular case, what we're basically saying is use a non-validating login module, which means basically take any credentials that are there. It's the sample dummy one that we actually use. But here's a case where you may want to actually configure it such that it points to your enterprise LDAP directory in order to actually authenticate, really authenticate against a set of users into the enterprise itself. And again, we have sample configs for some of these all shipped as part of the Worklight sample. Once you've configured security, what actually happens when you actually have a protected resource is the challenge goes back if a unsecure request comes in. The challenge request on the client side is handled by something called a handled challenge. In this particular case, I'm basically printing out the fact that we're actually challenged. In the sample that I do here, I basically just hard code in a user ID and password. But it's at this point in time that if you wanted to then pop up your own client-side login box in order to actually have a better model, not just present a web view, but actually have a client-side model of something that you actually build in Xamarin, this is where you would effectively call your login window, right? Accept the credentials from the end user, and then pass this part of that handle challenge response back to the client itself. In order to hook up challenge handlers, the challenge handlers are all registered as part of that initial client-side connect into the to the Worklight server itself. From a security model, this whole challenge handler mechanism, this whole configurable authentication model mechanism is actually very flexible. In many cases, especially for a lot of banking clients, we do multi-factor authentication. We do step-up authentication. Step-up authentication is a little bit different in that it may allow you to access a number of different resources, and then you may find out that, for example, you want to drive a transfer. The transfer is over, let's say, $1,000. You want to actually ask for an additional level of security just to revalidate that the guy is who they said they are as part of that sort of stuff. So that's all possible. The other thing that's possible is actually handling single sign-on within Worklight itself. Part of what we've done on the device is we've actually provisioned that device identity. That device identity is actually provisioned, and it's actually stored in the device OS key store, so it's kept secure by the OS itself. Because the device OS key store is managed by the OS, because most customers, if they're building multiple sets of applications, those applications are signed by the same signing key. That device ID is actually available to be viewed by both applications. So this is where, on the server side, as the request is actually coming across over HPS, you could effectively log on in one application. We'll keep track of that information in the session on one part of the Worklight server, and then if you come in through another application, will recognize that, oh, we already understand that there's a device ID that's actually registered. It's participating as part of that session. We'll copy it over to the other session, and you can use the credentials for follow-on calls throughout the Worklight server and into your backend systems. So it's something that we see our customers doing that are building kind of groups of applications as a way to manage single sign-on across a set of applications itself. In this particular mechanism, it keeps all of the security stuff done on the server side, and it keeps you from actually having to write passwords and things like that within the device OS key store. So it's a much more secure model. That third part, the third value proposition from a Worklight perspective is that they actually help you manage the applications. This is an example of a Worklight console. So when you create that application itself, you're effectively going to see a set of artifacts that are going to allow you to manage the application. Here's that Android artifact that represents the client, or I should say the server-side interface for the Android application. Here's the iOS version of that same sort of application API from that perspective. Any adapters that you define will also be listed within the Worklight server itself. Part of managing the application is we've built into the system the ability to actually disable the application and actually keep the application enabled and specify a message back to the end user itself. The value proposition of things like active and notifying would be, I know that I'm taking the system down over the weekend. I may want to warn my users before I actually do this. This provides a nice mechanism to actually specify that information, send it back to the client side, such that when the end user of the application opens the app itself, they'll actually get a message warning about what's actually happening. In the case where its access is disabled, many times we've seen customers build applications, they'll get the application out there, and then they'll realize that they actually haven't built anything into the application in order to disable it. There's no mechanism to force users to upgrade. Why would you want to force users to upgrade? It may be because you have security exposures within your application, that you're disabling server-side resources, and a lot of these things are things that you actually can't test with. So this gives you, out of the box, some features, some capabilities for building it in, and they're features that developers don't even actually have to worry about. To disable or notify an end user, you would effectively specify a message of what you wanted to do, perhaps give it a new URL to a new version of the application that actually gets downloaded, and you're good to go. What will eventually happen is on the client side, when the application is disabled, the client side actually talks to the server. A dialog box would actually come up specifying the information that actually came out. Of course, I used a different text for this capture itself. In the case where it's a service notification, what you actually may get is, this is that active and notification side, a message on, this is an example on iOS that we're upgrading the server this weekend itself. So again, it helps keep the end user understanding kind of what's happening on the server side from that perspective. Part of what we actually have in Worklight is this remote-controlled client-side log collection. So part of the APIs that we actually provide as part of the Worklight server and the client side available to the Xamarin developer is to be able to actually define different log levels of APIs. Info, warning, fatal, error messages that can actually be logged on the client side. Part of what the Worklight client component SDK does in working with the server is actually able to capture that information, and at certain points in time, it'll actually send that information over to the server side, such that now users can actually figure out a little bit about what's happening on the client side of the application itself. Again, a very powerful feature. And again, we only send that information in on initialization, resume requests. All of this is customizable. But again, it gives the developer a little bit of ability to actually view and modify that. Also built into Worklight is an analytics server in order to actually capture lots of different information as part of this. Out of the box, we're looking to address user adoption, user actions, performance metadata, providing information about what's actually happening to the client, provide a default set of reports out of the box, and then give the ability to actually have the user query and look for information. It's actually an Elasticsearch engine that we've actually built into the Worklight application itself, all managed as part of this. Within this application, we can give you information about API requests coming from the client itself. Some of these APIs are actually going to be internal APIs that we use for things like push notification, registering the device, querying APIs itself. But this gives end users and developers know the amount of time it takes for a client request to even reach the server itself. For adapter usage, all of that information is actually specified such that you can actually look at the response time, or you can actually look at the amount of data that's actually transferred for some of that information itself. Client-side log selection is actually fairly easy itself. There's a set of documentation that exists underneath the component itself. And the typical foundation is a typical foundation that you would find for most enterprises coming into Worklight itself. Worklight's typically sitting back in the enterprise itself. There's a SSO server that sits within the DMZ. And most enterprise applications set these things up as a clusterable model. If there's any questions upon it, all of this stuff is freely available. The CLI is freely downloadable. Again, it contains that full Worklight server that's sitting in under there. The component's available. It's there in the App Store right now. If there's any questions, just go to the Stack Overflow, look for the Worklight tag, and we actually have people monitoring that all the time. At this point in time, I'm going to transition to a little bit of demo. I have a little bit of okay. So this is effectively a sample application itself, which represents a banking application. You'll see that there's the four project structures for the common information itself. You'll see information for Android, for iOS, and for the Worklight application. In this particular case, there is a single interface under the client structure, which represents the calls to Worklight. In this particular case, there's a call to invoke accounts, get transactions, invoke transfer funds, and drive that initial login. I've also stubbed out code in order to call push. Underneath the implementation, this is sample code, which basically is all of the code to connect up into Worklight. So here's the case where I'm invoking a analytics API to log data to the server that I'm actually trying to connect it. I could pass additional data to it, other JSON objects as part of that. But here is effectively the response connection. So let's take a look at a little bit of what the sample looks like if I were to actually run this. The demo looks like if I were to run this. So this is a quick demo app that the Xamarin team actually helped build up. This is leveraging all of the XAML form stuff. In this particular case, I would log on. The logon is effectively going to drive the retrieval of the transactions back there. So it's pulling this data back from the Worklight server itself. If I were to click on one of these, it's going to receive a set of transactions again back from the transaction server. So this represents the transactions under the account itself. From driving a funds transfer, I could transfer funds from one application, transfer $20. And now it's updated that information all as part of that. Now the cool part of this is if I were to look at the Worklight information itself, this happens to be the Worklight server. I could go and disable this application. Or actually, let's specify a little message to say hi. The rule was specified, was accepted. So now if I were to issue another request, I'd actually get a service notification, kind of demoing that. On the analytics side, this represents the dashboard of all the information that's actually coming back and forth. So I can actually see the number of applications. I could see how many of the applications coming in would be iOS versus Android. I would see my adapter usage as part of this. In this particular case, what I did is I actually created 3 adapters. I have an adapter which represents kind of a simple JSON object. I have an HP adapter, which is going to loop back around and actually call that simple adapter. And then I have another adapter, which is going to call that sample, that RSS.cnn.com sort of feed. The cool thing about this is if I were to go look at my adapters, I'd see that I had this many total calls. I can see the procedure calls that are actually getting called and get a view for what that actually looks like. I could see the calls of where they're actually coming, or from a hit side, if I have multiple servers, I could see which of the servers the adapter hits are actually coming from. Perhaps I'm not getting the right balance from that perspective. The other sort of kind of cool thing here is I can actually see a network summary. So here's a case where it's looking at round trip time of all of the adapters. I can actually filter down the adapters such that if I looked at my bank adapter, you'll see that the server response time is 41 milliseconds, but you can see it's really not doing much in that adapter itself. If I were to look at my HP adapter, which is that loopback adapter, you'll notice that my response time kicked up to 53 milliseconds, and I'm doing a little bit more work. If I go to the HP adapter, which is calling that RSS.com feed, right, I'm now suddenly calling a lot of back-end response time in order to actually call that information itself. So I now can start to use some of this metadata to actually understand what's the experience like getting information back from the client side, as well as looking at the amount of data. The other sort of information I have is all of that activity information is actually captured here, so all of those activity calls that can be specified. And then I'm routing all these client logs into the system itself, so I can actually search the client logs. Here's a case where out of the messages that are coming back, I have 640 messages coming back. I can now start to strip down the level of information of those messages, all from that information, and I could do the same thing on the server side. So we're piping the same server-side logs in here. In this particular case, I got 1,600 messages within the server-side logs. I could look for just severe warning areas, and I could use this as a way to effectively filter down and understand where am I having problems within my application, within my adapters itself. So that's my quick whirlwind tour of Xamarin and Worklight integration. Again, there are links available in the presentation. There's a resources page as the last part of my presentation. We're going to make this available. That said, I'm done. Any quick questions? We'll take a few questions, and I'll cut it off in order to give the next speaker a place to prep.
Hi. How do you deal with MDMs? Are you compatible?
So the question is, how do I deal with MDMs? Are you compatible? We are compatible with MDMs. Most MDM vendors, I mean, that's not really a question of Worklight. That's really more of a question of Xamarin. At the end of the day, MDMs manage the application itself. In this particular case, Xamarin is building the application itself. Therefore, yes, we're absolutely compatible with applications with MDMs from that perspective. We're also doing integrations with various MDM vendors in order to actually try to tie the device IDs back that are provisioned by the end vendor into something that you can actually look at from the server side within Worklight itself. I'll tell you what, again, we're out of time, and I know that they actually want to set up, so I'll be available after this to answer questions, and thank you very much.